Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic packing efficiency. Now we have studied about crystal lattice and we know that crystal lattice is made up of a large number of unit cells and every lattice point is occupied by one constituent particle. And we also know that there are some void spaces in the unit cell, whatever may be the type of packing. So in order to understand that, we need to see packing efficiency. So what is packing efficiency? Packing efficiency is the percentage of total space which is filled by the particles. So if we have to put it mathematically, we find that packing efficiency is volume of one atom divided by volume of the cubic unit cell multiplied by 100. Volume of one atom divided by volume of cubic unit cell into 100. This is the case in case of packing efficiency in simple cubic lattice, because in simple cubic lattice, in simple cubic unit cell, there is only one atom. So we will take volume of one atom. Okay. So in case of simple cubic lattice, packing efficiency is given by volume of one atom divided by volume of cubic unit cell into 100, because we know that in a simple cubic unit cell it contains only one atom. Now if we see this structure, you see this is a simple cubic unit cell. In this, if we have to find out the packing efficiency, then first we find out volume of one atom. Now volume for one atom, before that we have to see some considerations. In this we see that the atoms are at the corners of the cube, as you can see in the figure. The atoms, all the atoms wherever present, they are at the corners of the cube. And the particles touch each other along the edge. You can see the particles touching each other as is given in this figure. The particles touch each other along the edge. Side of the cube is small a. Side of the cube is denoted by small a. Any side we can take as small a. Radius of the particle is r. So you see a can be given as 2r. If you see this area, this is a. Here two radius are fitting, you can see, from E to D. It is equal to small a. That is also equal to 2r. So we find that a is equal to 2r. Now the volume of the occupied space is 4 by 3 pi r cube. Okay. And volume of cubic unit cell, volume of cubic unit cell is equal to a cube. Volume of cubic unit cell is equal to a cube. What is a? A is equal to 2r. So this will be equal to 2r whole cube. 2r whole cube becomes equal to 8r cube. 2 into 2 into 2, 8r cube. So we get it as 8r cube. We know that a simple cubic unit cell has one atom, that we have seen in the previous video. Few videos back I have discussed it. Now the volume of occupied space. Volume of occupied space is 4 by 3 pi r cube. Volume of the occupied space is 4 by 3 pi r cube. So packing efficiency will be volume of one atom divided by volume of cubic unit cell. Volume of one atom, because here only one atom, divided by volume of cubic unit cell. For one atom it is 4 by 3 pi r cube. For cubic unit cell, just now we have seen it is 8r cube, because a cube equal to 2r whole cube, that is 8r cube into 100. When we solve this, we get pi by 6 into 100%. On further solving, we get it as 52.36%. We can round it to 52.4%. So this is the case for simple cubic lattice. In case of body-centered cubic structure, we will find that the atom at the center will be in touch with the two other atoms diagonally arranged. You can see here, at the center whichever atom is there, it will be in touch with the other two atoms which are diagonally arranged. Okay. So here we have to consider in this structure two triangles, EFD and AFD. EFD and AFD. So one by one we see. In case of EFD, in triangle EFD, you see A square plus A square will be equal to B square. So B square is equal to A square plus A square. B square is equal to A square plus A square, that is equal to 2A square. So B will be equal to square root of 2 or root 2A. In triangle AFD, C square will be equal to A square plus B square. You see here, AFD, AFD. So C square, this one, C square will be equal to A square plus B square. Okay. But B square is 2A square, so it becomes A square plus 2A square, that is 3A square. So what will be C? C will be equal to root 3A. Now length of body diagonal C is equal to 4R. From here we go back to the diagram once again. You can see small c, this one. Small c is equal to 4R. Here this is 1R. Here second R, third R and fourth R. Because C is equal to, it is diameter, so 2R. So R plus R plus R plus R, 4R. So C is equal to 4R, where R is the radius of the sphere, which is representing atom. All the three spheres are along the diagonal and they are touching each other. So C is equal to 4R, but C is also equal to root 3A. So we can write that root 3A, here we got C is equal to root 3A. So root 3A is equal to 4R. So if we shift root 3 to the other side, we get A equal to 4 by root 3R. Or from here we also get R is equal to root 3 by 4A. Total number of atoms is 2 in this case, we have seen earlier. So volume will be 2 into 4 by 3 pi r cube. 2 into 4 by 3 pi r cube. When what is the volume of the cube? Volume of cube is a cube. What is A? A is equal to 4 by root 3R. So we have to say 4 by root 3R whole cube. So packing efficiency will be volume, total number of atoms, so 2, so volume of that is 2 into 4 by 3 pi r cube, that we have written on the numerator, divided by volume of cube is A cube, this one 4 by root 3 R whole cube, this one, into 100%. When we solve this, 2 into 4 by 3 becomes 8 by 3 pi r cube, divided by 4 by root 3 R whole cube, 4 into 4 into 4, 64. Root 3 into root 3 into root 3, 3 root 3, R cube. R cube will get cancelled. On solving this, we get 68%. So we have seen the packing efficiency in this case also. Students, I hope you could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to my channel. Thanks for watching my video. Thank you.